Okay, today we're going to look at map software and its prediction functionality to enable you to create robust reflow profiles or improve the ones you already have. Today we're using version 3.22n, but the prediction feature should be on just about any version that you may have installed. We always encourage you to install the latest version for the most functionality and compatibility with our products. So in our YouTube tutorials, which can be found under this ECD training tab, we have other tutorials on how to navigate the software. This one's specifically on prediction, and we'll be overlapping some other features with our machine model overlay. I want to go over some of the dependencies that prediction has. You've heard the term GIGO, garbage in, garbage out. The same is true with our software. We have three main dependencies to produce good predictions. That is the machine model, its dimensions in time or length. The second one is the recipe or the set points that produce this reflow profile, including its conveyor speed and the zone set points. And then we have its location or overlay on the profile graph itself. We can have the correct recipe, the correct oven model, and not have it placed correctly over the thermal data to be interpreted correctly. So those are the three main dependencies, and we'll quickly go over those right now. Our machine models, we go over in another video, but basically we need to measure the length of every zone. We have a collection of predefined ovens. Yours may or may not be in the list, and depending on the manufacturer, it may or may not match. There are some very prolific oven manufacturers that have model numbers that have been in production for 20 plus years, and there can be small variations and or modifications. So the only way to truly find out if your oven model is correct is to get a tape measure out and measure it. To do that, we encourage you to start at the first zone, and you can do it either in an accumulative fashion where you just lay the tape measure out and you measure from the beginning of the first zone to the midpoint between zones 1 and 2. Or you can do it individually where you measure again to the midpoints, add in each individual zone length. We do include the cooling zone. Almost half of your time above liquidus happens in that cooling zone, so we include the cooling zones in our prediction as well. So going back to our oven model, we would put in our individual links in this column. If you'd like to do it accumulative, you need to turn that feature on by hitting this More button and activating this checkbox to turn on accumulative zone measures. We only show top set points. 99% of the time, your top and bottom set points are going to be identical. If for some reason you have a profile with slightly different bottom side set points, you can also deactivate that top and bottom are the same, and then you'll see a place to enter your top and bottom set points. This is mostly for second side reflow kind of applications. We define how many zones we have, both heating and cooling. We've defined our links, and we hit OK, and now that is placed on our thermal profile. So this is how we represent that. The lengths of each zone are represented by these vertical lines. The set point of each zone is represented by these horizontal lines with the number attached. We look at our alignment. The software gives you an automatic way of aligning this to the profile by aligning the peaks. If we tell it to align the peaks, it will automatically align our oven model so that the end of the zone with the highest set point is lined up with the peaks of the profile, which is usually a pretty good way to align it. If it doesn't get it exactly right, you can always grab the process origin and move it left or right. There are some subtle indicators of where these zone boundaries are that we want to double check. So you can see these natural saddles are where we have a separation in temperatures. Those are usually the gaps between the zones where it's not actively being controlled. So we want to see if our zone boundaries match up with those natural saddles. And in this case, it looks pretty good. Also, you be inclined to want to set your process origin here where the initial heating happens. This is usually hot air coming out of the beginning of the oven or the entrance to the oven, not actually where the beginning of our first controlled zone happens. Although it's interesting that some board preheating is happening out here, we can't really affect this with controlled zones. So we're only interested in what we can control in the oven, which are these individual zone settings that we have. So we've got our oven model correct. We've got our recipes entered correctly. We've got it lined up to our profile. You can see we have our solder paste or process overlay here, and we're not really hitting the requirements the way we'd like to. So now we can go into prediction and bend this profile to better meet our requirements. You can see our time above liquidus, in this case 221, is low at 20 some odd seconds. Our maximum temperature is also low, not getting up hot enough. So we can now, as we hover over these set points for the zones, we can now adjust these to come up with a new recipe that better meets the recommendations from our solder paste. You can see as I hover over that set point, you get a pop-up that says that you can click and drag. And as we click and drag, the profile will update dynamically to its new predicted shape. So we can go through here and quickly modify some of these values. We don't want to go too excessive on how much variation we have between zones, because your oven needs to have, be within 30 to 50 degrees of each adjacent zones so that it can maintain those temperatures efficiently without having too much influence from the adjoining zones. So you can see as I am adjusting these, our data in our KPI table is also adjusting dynamically with that. And as I get this set, I can come up with a new recipe, and I'm going to turn this down just a little bit, that better meets the recommendations from our solder paste. My time above is still a little bit shy, but better than it was. And if we wanted to, we could start playing with conveyor speed now to try to get our time values more in line with what we want. So once we get this exactly the way where we want it, we can then save this as a prediction. It always puts this prefix in here to let you know that this isn't real data, it is predicted data. And then you would go out to your oven with your assembly, you would enter in these new values and then confirm that in fact this prediction met the requirements for your assembly. Our prediction algorithm is extremely accurate, ensuring that you have those 3 dependencies correct. You'll find excellent results using this prediction. Probably the highest value feature in the software to help you save time.